Hello again, everybody. This is Chris Ostrowski from About. Have you ever wanted to learn about service-oriented architecture and you wanted to learn about all of the different aspects that go into developing a SOA application? Stay tuned. This set of video tutorials is just for you.
The following video is brought to you by Oracle professionals at About. About, the right staff, at the right time, at the right price. Please visit our website at www.about.com.
For those of you who are at Oracle Open World 2014 and attended my presentation, Deep Dive, a SOA application end-to-end, you'll remember that I had 45 minutes to do my presentation when in fact it was about a 4.5 to 5 hour presentation that I had designed for Oracle Open World. So I obviously wasn't able to get to everything that I wanted to talk about. So I'm creating these video lessons to go ahead and supplement what was meant to be contained in that presentation. So hopefully this will give you a real good background on SOA and SOA applications and how to create a SOA application end-to-end. My real motivation for creating this presentation was the fact that there's a tremendous amount of information out there about service-oriented architecture, but getting all of the pieces to fit together can really be a challenge for a lot of people, and I really struggled with it for a long time. And I was really, my motivation for creating this presentation was to bring all the different pieces together so that you can see the benefits of what service-oriented architecture can do for you inside of your organization. So let's hop into the slides now and take a look at SOA application end-to-end. This video is sponsored by About. It's a company that I work for. It's really a dynamite site. I encourage you to go to the About website. There's a lot of real nice material there. There's a lot of white papers and real interesting information. There's videos, a lot of information that you can get about Oracle databases, middleware, the e-business suite, Fusion applications, a tremendous amount of information there. I also maintain my own blog, fourthmonth.wordpress.com. Anytime something interesting happens in the Oracle community, I usually go out there and write about it. I don't work for Oracle, so I'm not limited by the Oracle company line. So I try to give you an honest review of what I think is going on inside the Oracle world there. So if you have any interest in seeing things that I write about for the Oracle, about the Oracle world, please don't hesitate to go there. In this presentation, we're going to have presentation slides, obviously. We're going to talk about a whole bunch of different videos where we're going to talk about a lot of the different aspects of service-oriented architecture, and in particular, how Oracle implements those technologies. So there's a lot of different tools and a lot of different things that you can license from Oracle that'll make your SOA development and administration of those complex environments a heck of a lot easier. So in this presentation, we're going to go through presentation slides. There's also going to have demos that go through all the different aspects of what it takes to build a SOA application from scratch. This is where I got really frustrated when I was trying to teach myself about service-oriented architecture. There's so many different pieces of information out there, but just kind of bringing them all together into a cohesive whole, I really struggled with that for a long time. So that was part of my motivation for creating this set of slides and this presentation in general, was just to kind of bring everything together so that it makes a heck of a lot more sense, so that you can talk about SOA intelligently inside your organization. When people say to you, you know, should we be moving to this technology? What is it going to, what are the benefits that we're going to get inside the organization? Why should we make the learning effort or the educational effort to get all of our developers and administrators and project managers up to speed in service-oriented architecture technologies? I was hoping that this presentation would be able to kind of bring all of the pieces together so that you can talk intelligently inside your organization about the types of things that SOA can do for you. The videos, we're obviously creating the video here as part of this presentation. All of these are provided at our website, www.about.com. So you can find a tremendous amount of information on that website, as I mentioned earlier, and certainly all of the prerequisite materials that go along with this presentation, you can get there. This presentation can't cover everything. I could certainly talk about a lot of the different aspects of service-oriented architecture and create 4- and 5-hour presentations easily just on those individual topics. If I'm going to create a presentation that covers all of the different aspects of service-oriented architecture, there's just some things that we can't really talk about here, just for scope. This is not about Java or XML. Service-oriented architecture technologies are not language-based. They're not just based on, let's say, Java or PL SQL or C#. As we're going to see as we start going through the presentation and the technologies and the demonstrations, one of the benefits of implementing a SOA-based technology inside your organization is the fact that you're not limited to a certain programming language or operating system or database or middleware tier. SOA technologies are based on standards. And those standards, as long as they're adhered to in whatever programming language or operating system that you're talking about, you'll be able to implement a SOA-based solution. And you should be able to integrate all of the different disparate systems inside your organization relatively easily if you adhere to the rules that are set up within SOA, all of the standards that are built into it. So we're not going to talk about Java. We're going to talk about XML a lot, but this really isn't a tutorial in XML. For the first demo that we get into, we're going to start taking a look at XML files, and we're going to read through an XML file and see how that's kind of our starting point for building a SOA-based application. But we're not really going to go through the basics of how XML works. I'm kind of assuming that the readers, the viewers of this presentation have a basic knowledge of XML, what it's intended for. And again, we're going to be using Java as our programming language as we go through the demos, but you certainly don't have to do it that way. You don't have to use Java. I'm just going to do that because Oracle's tools are really based around Oracle JDeveloper, Oracle WebLogic, and those are Java-based environments. This is also not a JDeveloper tutorial. We're not going to talk about how to do things in JDeveloper. We're not going to spend a lot of time doing that. We're going to show you how to do these things inside of JDeveloper, but we're not going to spend a lot of time actually going through a tutorial, and this is how you would do this. There's plenty of sites. Oracle has a tremendous amount of videos that are out there on how to do different things inside of JDeveloper. If you want to learn more about how to do those things, I certainly encourage you to go to those sites. And at the end of the video, I'll have a whole bunch of reference materials that you can use so that you can find more information about JDeveloper. But again, this is not a JDeveloper tutorial. It's also not a WebLogic tutorial. WebLogic is a very complex middleware environment. You can do a tremendous amount of things inside your organization, inside of WebLogic. And one of the real challenges becomes, where do I put my code? Do I put my code inside of WebLogic, inside of an EJB or a JSF, or do I put it as part of a JavaScript? There's also all of these really new exciting JavaScript frameworks like Node.js and AngularJS. One of the real challenges comes down to, where do I put my code? Where's the most efficient place to put my code? Do I put it in the Oracle Service Bus? You can certainly put it there also. There's no one right answer, but you should have an understanding, and hopefully this presentation and these videos will give that to you. You should have a basic understanding of what are the pros and cons of being able to put your code in all of these different places inside of your organization. But this really isn't designed as a WebLogic tutorial. Again, there's a lot of really great reference materials on the internet where you can get that information about WebLogic. We're going to use WebLogic, but we're not going to actually go through a tutorial here. We're not going to spend time with installation guides, how to install a database or the WebLogic server or JDeveloper. Again, there's plenty of other reference materials to do that. This is really intended as a high-level overview of SOA principles so that you can understand how SOA works and the types of benefits that you can use inside your organization. It's also not an administration guide. It's not intended to show you how to set up WebLogic or JDeveloper or do any of those things. We're going to do some of those things as part of our demonstrations, but it's really not intended as an administration guide for any of the tools that we're going to use here. According to neuroscientist Lotto, the creation of all new perceptions begins in the same way, with a single question: why? In that sense, the most dangerous word in history. As soon as you ask that question, you open yourself up to the possibility of change. Asking why may be the hardest thing for people to do. One of the things that I really struggled with was that there's so much information that you have to know about service-oriented architecture that a lot of the materials that I was using to teach myself about SOA never seemed to answer the why question. They spent so much time saying, this is how you do this, this is how you do this. And I really struggled with why. Well, why do I even care about doing things in that way? One of the things that you're going to have to accept if you're going to embark with service-oriented architecture inside of your organization is that you have decision points at virtually every single thing that you can possibly imagine when it comes to putting your system together. Again, this will be a lot more obvious when we start going through some of the examples and we start looking at some of the demos. There's a tremendous amount of flexibility with SOA that gives us the ability to set up our SOA environment exactly the way we want it. But the challenge that goes along with that is understanding all of the different permutations, all the different ways that we can set up our system, and why that might be important to us. In the simplest type of environment, in a web-based environment, I usually think of, like an Oracle Forms application that's being developed or deployed over the web, where you run a traditional transactional-based system. You might pull up customer information or inventory information, make changes to that, write it back to the database. There's a lot of magic that's going on behind the scenes to make all of those things stay in place, particularly when we talk about a stateless environment like the World Wide Web and a stateful environment like an Oracle database. Getting those two things to talk to each other and stay in sync is a real challenge. Oracle Forms hides a lot of that complexity away from you, and you can go in there and make changes if you want, but for the majority of applications, developers usually don't worry about all of the magic that's happening behind the scenes. When we're talking about Java SOA-based applications using a tool like JDeveloper and Oracle WebLogic and then an Oracle database on the back end, there's a lot of different things that we have to think about and make decisions on as part of our application, as part of our architecture. And you may say to yourself, well, aren't there default values that I can take for all of these things? Yeah, there are, but it's still good to understand all of those different pieces. And asking those why questions, well, why do we want to set it up that way? Why do we want to put the code here? Is really going to help you in the long run when it comes down to actually deploying your SOA-based application. So let's start with an introduction here. SOA, by its very nature, is not very PowerPoint friendly. When you create PowerPoints, there's a whole bunch of different books out there about style guides for PowerPoints and the presentation secrets of Steve Jobs and all of those sorts of things. One of the things that they tell you is not to have slides with too much information on there. You want to keep your presentations very conversational. Unfortunately, SOA really doesn't lend itself to that. SOA kind of forces you to understand a lot of these basic concepts from scratch. And unfortunately, in a lot of these slides, I'm going to break kind of the main rule of creating really interesting PowerPoints by having too much information on the screen. I know that's there. I don't know any other way around it. You have to kind of have a basic fundamental knowledge of some of these SOA principles before we can really start making making good decisions on how to implement our SOA technologies. So by its very nature, SOA is not very PowerPoint friendly. I'm going to do my best to try to keep it interesting and not spend a lot of time on those slides, but there are a couple of slides in here that really do have a lot of information on them. So you already know the what. The what is service-oriented architecture. You already know the who. The who is going to be the way Oracle implements or gives you the options to implement a SOA-based technology, and the organization that you work with, the developers, the project managers, the people inside your organization who are going to be working with this. Google is great for the how. How do I go through and do all these types of things? How do I create a web service? How do I deploy a web service? How do I set up security that goes with a web service? The real tough questions are going to be the why type questions. Why do we want to implement this technology? Why do we want to adopt this framework? Why do we even want to do so inside of our organization? Why does it make sense from a business standpoint, from a financial standpoint, from a competitive standpoint? Why do we want to do these things inside of our organization? That can be a real challenge for a lot of organizations to answer those questions. But if you come at this different types of things out and tying a lot of those decisions back to the way your organization does business, you'll have a much greater chance of implementing a successful SOA-based application or SOA-based architecture inside of your organization. But a lot of times the why questions are kind of tricky because, again, a lot of the older technologies, a lot of the legacy technologies hid a lot of that implementation details away from you. One of the real benefits of a tool like Oracle Application Express is the fact that you don't have to worry about all of the magic that's going on behind the scenes, how Oracle maintains what's called a persistence layer. We're going to talk about that in a little bit. How it handles a stateless environment like the web and a stateful environment like a database. How it handles security. How it does all of those different types of things. The user interface. Oracle Application Express hides a lot of those details away from you. Oracle Forms hides a lot of those details. So a lot of times developers not only are not used to asking those types of why questions, they don't even know where to interject the question of why this is being done this way. Hopefully this presentation will help you out by giving you a lot of those why type questions as part of the demos that we start working through. With SOA, a lot of why questions will have to be answered. And I gave you the example a little while ago of where a simple piece of code might live. You might have a little piece of code that, let's say, validates a field on the screen, and you want it to execute immediately as the user enters information into the field or leaves the field. There's a whole bunch of different places where you can put that code. You can put it into something called a Java Server Faces page. You can put it into a JSP. You can put it into the database. You can put it at the middleware level. You can put it into something called the Oracle Service Bus. There's a million different places that you can actually put that validation code. Where's the best place to do it? Where does it make sense? Why do we want to put it inside the service bus? Why do we want to put it inside of a JSP? Those are the types of questions that you really have to answer. And again, there's no right answer. Every situation is going to be different. Every organization is going to be different. The technical expertise inside of your organization, the amount of cooperation that your business managers and business architects will be working directly with your developers and your system architects. Every organization is a little different. So finding out what's appropriate for your organization can be a real challenge. I put this comic strip in there because this always cracks me up, you know, all of the different buzzwords out there, and then finally somebody says, well, what about the return on investment? Don't bother me with buzzwords. That's really a lot of the challenge that goes behind service-oriented architecture. There are a lot of standards that go on behind the scenes. And as soon as developers hear that, they start shaking their heads and they go, oh, geez, standards, you know, I don't want to have to, you know, it's hard enough trying to write a really good application that has a good user interface and security and performs well and models all the business rules effectively. Now there's all of these standards that I have to conform to. To a certain extent, yes. Your developers will have to understand the different standards that are out there and conform to those standards. That's the only way a service-oriented architecture solution works, is if you conform to the standards outlined by the SOA architecture. The good news is that most modern development tools will hide a lot of those details away from you. They will generate the code. They will generate the XML files. They will generate the configuration that you need in order to make SOA work effectively. It's not true in every case. There are certain things that your developers will have to understand before they can build SOA-based applications efficiently. But for the most part, most modern development tools will hide a lot of those implementation details away from you. I showed that building there because I wanted to kind of just show as a joke the way architecture has developed. And when I say architecture, I mean computer architecture has developed over the years. And it's kind of a hodgepodge. And finally somebody said after a while, you know, this is ridiculous. We're trying to build larger and larger projects, trying to do more and more different types of things inside of our organization with our IT systems. there's got to be some kind of way of architecting these things so that they work a heck of a lot better than what they do now. Large projects, we've all been involved in large projects that have failed miserably for whatever reason, whether it's communication or lack of commitment from the people who were sponsoring the project. There's a million different ways of doing that. SOA tries to address just about all of the different things that are out there and tries to make it a heck of a lot easier to align the IT world with the business world, to make sure that both of those things are in sync, so that when you go to build these large complex SOA projects, you can do so with a greater level of achieving success inside of your organization. So architecture started out in the 50s and 60s as real simple. You had a server on one end, you had a dumb terminal on the other. The dumb terminal was called dumb because it didn't do any processing. It simply was a conduit for you to put information into the computer and then get information back out of the computer. The server itself did all of the processing. It stored the data. If there was any type of business rules that went along with the application that you were working on, if you tried to graphically display any information on the screen as part of the application, the server did all of the work. This made things relatively simple in terms of architecture and putting things and deploying things out to end users, but it was very limited. It was limited by the capabilities of the dumb terminal, which really were pretty bad because the terminal by itself really didn't do any processing on its own. Again, it was just kind of a conduit for users to put information in and get information out. These systems also didn't scale very well because it was hard to kind of break out all of the different pieces that were there because everything was running on the server. The data store was running on the server. The business logic of the application was running on the server. Any type of displaying information on the screen had to be handled by the server the way it was formatted out to the dumb terminal. So this is a real simple way of deploying applications, but it's not very effective, especially in a modern environment. Phase 2, in the 70s and 80s and into the 90s, you had this client-server application model where the server offloaded some of its processing to the PC. So a good example of this might be a Windows application where the server would store the basic data in the information, but if you wanted to draw a pie chart or a graph, the PC would actually kind of take over doing that information. It would just get the data from the server and it would go through and actually draw the pie chart or the graph or format all of the data in the report. There might be some computations that were done at the PC level to actually change values in a report where it would do summaries and things like that. This helped out a lot in terms of scalability, but there's problems with this model too. First and foremost, the PC is doing a lot of the processing, which is great, but what happens when you're in an organization where some people are running Windows 95, some people are running Windows 98, some people are running Windows XP, some people are doing XP Service Pack 1, some people are running 2000 Service Pack 4, some people are running Macs, some people are running Linux. You're doing all of these different things. It can be a real challenge to do that. A second problem is, what if you have an application that has 5,000 users or 50,000 users and it comes time to update the application? You have to go to 5,000 PCs and update the application, or 50,000 PCs. Now, you can streamline a lot of this stuff with network services. Somebody could log in and you can automatically push an update out there. But it's not a very efficient way of supporting really large applications that are run by tons of people all over your organization, sometimes internally to your organization, externally outside of your organization. Not an efficient way to do things. The third phase really started to become popular as the internet grew in popularity. Late 90s, early 00s, you started getting into what's called N-tier architecture. And that's where you have a web server in between the server, which in this case is usually a database server where the data is actually stored, and a client. This solved a lot of the different problems that we had with Phase 1 and Phase 2. It scales a lot better than Phase 1 because I can add multiple web servers and have a losing my train of thought there. This scaled a heck of a lot better than Phase 1 because I can have multiple web servers with a load balancer in front of the web server. So as people accessed my application, I could have the load balancer send them to different web servers, and this could scale a heck of a lot better because I can keep adding web servers and then cluster them together to make sure that all the different pieces were working okay. And if I went from 50 users to 500 to 5,000 to 50,000, I could just keep adding web servers, and I could have the scalability of my application rendered much more efficiently there. Another benefit is I only have one place to update my application. So when it comes time to put in a bug fix or new functionality into my application, I don't have to go to 5,000 PCs or 50,000 PCs. I just have to go to my web server, or 4 or 5 web servers if they're all clustered together. Update my application there. Next time the users log into my application through their web browsers, they get the new version of the application. I also don't care, for the most part, what my clients are running. They might be running Chrome on a Windows PC, they might be running Firefox on a Linux PC, they might be running Safari on a Mac OS. For the most part, I don't care. I do in some circumstances. There's incompatibilities between different browsers that are out there, but for the most part, I really don't care how they're accessing my application, which means I don't care if they're running Windows 2000 Service Pack 1. I don't care if they're running Windows XP Service Pack 3, Windows 8, Mac OS. I really don't care. It's the browser itself that I really care about. So again, it gives me another layer of being able to roll out my application to a lot of people at the same time. And it takes away a lot of the limitations that we saw in Phase 1 and Phase 2. Phase 4 is when we start talking about distributed computing, and here's where SOA comes in. Distributed computing and service-oriented architecture allows us to just take pieces of our different servers, different pieces of our applications that are running on those different servers, and get access to them. So Phase 3 introduced this concept of web servers and giving us the ability to scale our application a lot easier. If I can now integrate all the different disparate systems in my organization, I can use SOA to do that, and it gives me a real easy way of getting the different types of information into my application that I need relatively easily. Service-oriented architecture introduces the concept of a web service, and a web service is just a small piece of code that does a very specific functionality. You can think of a real simple web service like a weather application or a stock quote or a sports application, where I pass in, let's say, a sports team and say, I want to see the schedule for this hockey team. I want to see all the most recent closings for this particular stock. I want to see the weather forecast for this zip code. And the web service then takes in that information, returns the information back to you in a format that again conforms to the standards that are outlined in the SOA standards. As long as I conform to those standards, I don't particularly care how the service is written. Our sports service might be written in C# and it's running on a Microsoft IIS server. Our stock quote might be written in Java that's running on an Oracle WebLogic server, and our weather application might be written in PHP running in some other server. It doesn't really matter. As long as they conform to the web services standards and the SOA standards, I should be able to interface with those different services that are out there, get the information I need as part of my application, and continue on. There's a lot of benefits to structuring applications and functionality inside of our organization. We're going to talk about that as we start getting into all of the different demos that go along with this. But there's a lot of advantages to doing it that way. So SOA also gives companies the ability to be agile. They can make changes relatively quickly. And let's face it, if you can't change quickly inside your organization, somebody else is going to come along and do it better, faster, cheaper. So every organization is trying to be agile. Web services and SOA technologies in general give you the flexibility to do that relatively easily. Systems need to be agile. Systems need to support the business. SOA is a philosophy, not a product. A lot of times people will ask me to boil down what SOA is in 1 or 2 sentences. And what I do is I say SOA is really 2 things. It's a set of standards that you have to conform to, and it's a philosophy. It's a philosophy about how you create your applications. You want to think of your applications not as these monolithic huge back-end applications like accounts payable or accounts receivable. You want to think of your applications as a series of different functionality pieces that you can turn into web services. So as part of your human resources application, let's say as an example, you probably have some kind of onboarding process where you'll have a new employee come in and then you give them access to all of the different systems, the networking system, building codes to get in the building, payroll, all of those different pieces. Instead of trying to build an application that handles all of those different things, you can think of each one of those specific pieces as a service. You might have a service that goes through and adds business building access to a new employee. You might have a service that adds them to payroll, adds them to different network access, maybe VPN access inside your organization. And then you can string all of those services together as part of your HR application. Again, there's a lot of benefits to doing it this way. It may not seem obvious right out of the box, but as we start going through some of the demos and some of the examples, it should be a lot clearer as to why there's a lot of benefits to structuring applications in this manner. Functionality in a SOA-based application is exposed through the different web services that are out there. How to manage and monitor those exposed services, how do we integrate internal and external services into our application, and how can code and functionality be reused. If you conform to the SOA standards, all of these things are available to you. You can reuse code over and over again. You can test code within an inch of its life and make sure that a particular piece of code functions the way it's supposed to, as opposed to the very difficult process of doing system or regression or functional testing inside of a monolithic application. There's a lot of benefits that go along with structuring applications this way, and hopefully they'll become more and more obvious as we go through more and more of these slides. Some of the basic SOA design principles, and here's where we start getting into some of those PowerPoint slides that have a tremendous amount of information on them. Again, I do apologize. I know this is bad design when it comes to doing a PowerPoint presentation, but it's really just about the only way that we can talk about all of the different pieces that go along with a good SOA design principle. So the first principle that goes along with SOA design is something called a service contract. Services adhere to communications agreement as defined collectively by one or more service description documents. This is just a fancy way of saying I'm going to have a predefined contract that says here's what I expect as input to my service, here's what I'm going to give you as output to the service. And again, because these are all based on standards, it should be relatively easy for me to build an application that queries what type of information is expected by the service and also queries the type of information I'm getting back from the service. Once I do that, it's relatively easy for me to go ahead and create an application that interfaces with that web service. I know what to pass it. I know what I'm getting back. As soon as I have all of that information, I can work from my development tools and say, okay, I know that the weather application is the weather web service is expecting a zip code and a number of days for forecast. I pass both of those in. Here's the information it's going to get back, and I can display it on my screen. That's the basics of the service contract. A SOA design principle also should follow what's called loose coupling. Services maintain a relationship that minimizes dependencies and only requires that they maintain an awareness of each other. What this is basically saying is, if one piece of the puzzle goes down for whatever reason, the whole system doesn't go down. So if pieces are loosely coupled together, I may not have access to the weather application. I may not have access to my stock application. But if they are truly loosely coupled, the application that references those web services doesn't crash by itself and still has other functionality built into it. All that other functionality should still work, even if the stock application or the weather application or the sports score application isn't available. I keep saying application. I should say web service. Even if any of those web services aren't available, the application itself should still be able to function. Loose coupling really implies that no one piece can bring the entire system down. We should abstract the web service also. Beyond descriptions in the service contract, services hide their logic from the outside world. And again, this goes back to what I was mentioning earlier. If you conform to the SOA standards that are out there, it doesn't matter what the service is written in. It doesn't matter if it's C#, doesn't matter if it's PL SQL, doesn't matter if it's Java, doesn't matter what operating system it's running on, doesn't matter what middleware is serving up the web service, doesn't matter. We don't really care. A lot of people will talk about what they call a black box, and SOA developers get kind of annoyed if you reference web services as black boxes. But you can kind of think of them that way at a very high level. Black box, again, is a principle where you don't really care what's happening inside the box. You know there's inputs, you know there's outputs, that's all you really care about. There's, again, a lot more that you need to think about when we're talking about web services and SOA principles in general is too often, because they will definitely get a little upset after a while. But once you have that understanding at that very high level, you can start moving forward with your SOA implementation. We also want the services to be autonomous. Services have control over the logic that they encapsulate, and only that. We don't want services to be dependent on other services. We start losing our loose coupling if that starts happening. We want to be able to reuse these services over and over again, and this is where the philosophy part of SOA design really comes into play. Developers usually aren't taught to think in terms of reusability of their code. But web services are much more likely to be used and reused inside of your application over and over again if developers have created them in a generic enough way that they can be reused in different scenarios. A good example might be something like a credit check service. You might create a web service that does credit checks, let's say in a store. Somebody might want to apply for a store credit card. So you might have part of your web service to go out there and take the user's yearly income, their social security number, goes out, does a web service check on their credit history, and then comes back and says whether you're going to approve them for a $1,000 credit line or a $2,000 credit line or something like that. That's a perfectly fine web service. But if the developer is smart enough, they can make that code generic enough to say, you know what, maybe in the future we don't just want to do personal credit checks. Maybe we want to do credit checks on organizations. Maybe we also want to do credit checks on government entities, something like that. If you think in those terms of saying, okay, how can I construct this web service so that it's generic enough that we can use it across a lot of different pieces, we can have the basic code in there that does the credit check, test it within an inch of its life, really isolate those pieces of information as part of the credit check, and then that credit check web service can be used across the entire organization. Maybe just not at the consumer level, maybe also at the back office level, like I said, where we're doing credit checks against organizations or government entities and something like that. So it's a philosophy of saying, how can I construct this web service and make it generic enough that it can be flexible, where I can add on a lot of different pieces to this web service and make it usable across a lot of different disciplines inside my organization. By its very nature, web services are defined to be stateless. Again, they're not dependent on other pieces inside of your application. Again, we would lose our loose coupling if we did have that. So services minimize resource consumption by deferring the management of state information when necessary. We're talking about Oracle databases, right? Oracle databases inherently are stateful environments. They have to be stateful. How do I maintain security in a database if it's a truly stateless environment? There has to be some kind of state to maintain who I am, who's trying to query the information out of the database. Do they have access to that information? Is it logical for them to be seeing this type of information? So in most cases, we want our web service to be stateless. In those cases where we are dependent and we do have to make them stateful, we have to be careful about not losing our loose coupling by making them dependent on other things outside of the web service. But sometimes there's just no way around it. If you'll notice the way that number 6 is worded here, we want to minimize resource consumption by deferring management of state information when necessary. So that means we may have to write supplemental code that's outside of the web service to maintain its state. This isn't a very good SOA principle, but sometimes there's just no way around it. Sometimes it's just the only way you have to do. We also want it to be compostable. Compostable means services are effective composition participants regardless of the size and complexity of the composition. There's something called a composite application. And a composite application is where you take a whole bunch of different web services and then kind of mash them all together into an application. So an example that I gave earlier of like an onboarding process. You may have a whole bunch of different web services that add network accessibility, add building codes so that the new employee can get in the building, add them to HR, add them to payroll, add them to all of the different necessary pieces that you need to. If you have web services for all of those different pieces, you can then create a composite application for your onboarding process that goes from one service to the other to add that person to all of the things that they need to inside of your organization and get them onboarded. We also want to make our services discoverable. And again, this all goes back to the standards. As long as we conform to the standards that go along with service-oriented architecture, they all have to follow the same rules. If they all have to follow the same rules, there should be a way to discover the different services that are out there, what type of inputs they expect, what type of outputs they will produce. Once we have that, it should be able to build up a repository of web services inside of our organization so that when new applications are to be created or modified or enhanced, developers can easily look at the repository and say, oh, somebody's already coded this for me. Somebody's already done part of the onboarding process. Somebody's already done a credit check. I don't have to reinvent the wheel. I can take what's already there, use that code, and put it inside my composite application. That only happens after you've been using service-oriented architecture for a little while and you start building up this repository of services inside of your organization. So again, I used the analogy earlier of a black box. Don't use that term too much when you're sitting around hardcore SOA developers because they will get upset with you. But you can think of them as, at a very high level, as a black box of functionality. They take certain inputs. You don't really care about how the magic works behind the scenes, and then they produce some kind of output for you. A composite application is like a jigsaw puzzle of web services where you put together all of these different web services. What's the glue that kind of holds all of those web services together? There's something called BPO, Business Process Execution Language. We're going to talk about that as one of our demonstrations. We're going to spend a whole bunch of time on that. We're not going to get to that right now, but there is part of the SOA standard called BPO that allows you to take all of these different disparate web services and kind of mesh them all together as a composite application. So a service at its most basic level is something that a provider does for a consumer. So a service kind of just sits out there and says, okay, you want information from me, give me this type of information that I expect, and I will produce it for you. A real simple way is like your electrical service that is provided to every house in America. I shouldn't say every house, but is provided to most houses throughout the world. You don't think about the service. You don't think about the mechanics that go on behind the scenes. You know that you have outlets in your house and you plug things into the outlet and electricity is delivered to your computer, your television, or whatever it is you're talking about, and you just kind of accept that fact. You don't really think about all of the magic that's happening behind the scenes. A service at its very basic level is kind of the same thing. You might have a service like I gave an example of earlier of, providing weather information or stock quote information. You don't particularly care how the magic works. You just know that you provide it with this piece of information. And if we talk about electrical service, we're talking about a plug that comes with your computer, your dishwasher, your television, or whatever it is. And you plug it into the service, and the service is delivered to perform the function that you want to do. That's at its most basic level what a service is doing, but we're doing it at the software level. So a service, and when we're talking about web services in a SOA environment, has different elements. There's a contract that specifies what consumers can expect from the service. If we use a restaurant example, there's a really great book out there called SOA Made Simple. I very much encourage you to pick it up. A contract, if we look at a restaurant and going into a restaurant and saying I want to order food, the contract will specify the quality of food. We expect that the kitchen is clean and that it's going to be cooked properly. The price, the availability of food. You may have a restaurant like McDonald's, which doesn't serve breakfast food beyond 10 a.m. or something like that. how quickly I'll get my order. There's an interface, how you can use and access the service. In this case, if we use the restaurant example, we're talking about the waitress or the waiter, the languages that are on the menu that allow me to interface with the waitress or the waiter so that I can get information back and forth. And the implementation, the realization of the service is the chef's name, the tools they use, all of those types of things. For the most part, when you go to a restaurant, you don't care about the chef. You don't care about the types of tools they use. If you're going to a high-end, expensive restaurant, you want to be cooked by, some famous chef, then yes, you do care. But 99.999% of the time, you don't care about the actual implementation of the service. The implementation of the service is going to be the web service that we code and put out there. So we don't really care if it was written in PL/SQL, we don't care if it was written in C#, we don't care if it was written in Java, we don't care about any of those things. We just care that as soon as we provide the information, we're going to get the information back that we're expecting. So let's take a look at the technology stack that we're going to be using for the examples that go along with this web series. You're not limited to this. You don't have to use this technology stack, but because this is geared towards an Oracle audience, we are going to be using the Oracle tools that make up the technology stack. Again, you don't have to use this entire technology stack the way it's laid out here, but because we are Oracle professionals, because this is geared towards an Oracle audience, we're going to look at the different Oracle tools that are out there. The data source is an Oracle database. That's where we're going to store all of our information. Our middleware is going to be Oracle WebLogic. Oracle WebLogic was purchased from a company called BEA a couple of years ago, and it serves as the middleware tier for all of Oracle's offerings. If you've used the Oracle eBusiness Suite, you know that in version 12.2 of the eBusiness Suite, Oracle made a radical shift to go away from the original Oracle application server, and now it uses Oracle WebLogic as its middleware tier. Oracle Fusion Applications, the next generation of eBusiness Suite tools, uses Oracle WebLogic top to bottom. There is no Oracle application server anywhere inside of Fusion Applications. In this example, we're going to be using the SOA server that comes along with Oracle WebLogic, the BAM server. We're going to be using Oracle Service Bus to do our different examples and tutorials that go along with this. And the client is going to be any user running any kind of device that uses some kind of browser to access our information. For this example and this series of examples that go along with this video tutorial, I'm going to be using the Chrome browser. You don't have to use the Chrome browser. Maybe you're more comfortable in Safari. Maybe you're more comfortable in Internet Explorer. Maybe you're more comfortable on using a mobile device like an iOS device or an Android device. You can certainly do any of those things. We are trying to show as much flexibility as we can with our SOA processes, the way we create applications, so that if you want to use them in a traditional environment where you have someone accessing your application from a PC, if they're accessing it from a mobile device, if they're accessing it from some device in the future that hasn't even been defined or accepted yet, something like Google Glass may be the really hot technology 4 or 5 years from now, we can structure our applications so that we can use those different technologies relatively easily. The WebLogic architecture. Again, I'm not going to get too much into the administration or how WebLogic really works, but it is important to understand the basic fundamentals of how WebLogic works. WebLogic is defined around something called a domain, and a domain is made up of a bunch of different servers that work together. So every domain has an administration server. And you might say, well, why do I even need more than one server if I have a real simple domain? Well, the administration server provides you with the ability to manage all the different pieces that your users are going to interface with. In a real simple example, you have one managed server that goes along with it. The admin server itself is a full-blown J2EE server. So you could develop Java applications and deploy them to the admin server. You could if you wanted to. That would be an incredibly stupid thing to do, but you could do something like that if you wanted to. The correct way to do it is to create what's called a managed server, whether it's a J2EE server or a SOA server or a BAM server or an Oracle Service Bus managed server, and have those inside of your domain. You can cluster managed servers together, and this is where the advantage of having an administration server really comes in. With the administration server, you can manage all of the other clustered servers inside of your domain relatively easily, especially when you start adding different managed servers. You can set up load balancing and do a lot of really sophisticated things that way. So a typical domain will have an admin server. It has to have an admin server and one or more managed servers. What we're going to use, we're going to create this domain called a SOA domain, which again has to have an administration server, and then we create these other servers that we can get from Oracle to enhance our WebLogic application. So there is a server that Oracle provides called a SOA server. And a SOA server has all of these management tools that allow you to deploy SOA-based applications relatively easily and then manage those things, set up the security, look at the performance, doing a lot of really sophisticated things that go along with it. There's also something called a BAM server, Business Activity Monitoring, where we can look at the different pieces that make up our SOA-based application and start making business decisions based on that. We're going to take a look at the BAM server also. There's also something called an OSB. OSB stands for the Oracle Service Bus, and it's another layer that we can use to deploy our applications and deploy our web services, And once we have that layer available to us, we can do a lot of really sophisticated things at the OSB level. Some of the things that we can do is version our different web services. One of the real challenges that comes along with web services is how do you enhance them easily? I might create a web service for an onboarding process, and over time people start using it and they incorporate it into their composite applications. Well, what happens when, whoops, sorry, I just clicked here by accident. What happens when I enhance that web service, and now instead of taking 2 or 3 parameters, I take 5 or 6. And instead of returning 3 or 4 pieces of information, I start returning 6 or 7 or 8 or 10 pieces of information. I can't just deploy a brand new web service and kind of overlay the existing web service, because what happens to all of those people who built composite applications based on version 1 of my web service? I just broke all of their applications because now I'm taking in new parameters and I'm returning different sets of parameters. This can be a real challenge. The Oracle Service Bus is a real good way that you can have multiple versions of a web service out there that take in different numbers of parameters, so you don't break the different things that people have created using your web services up to that point. There's also a nice way of putting in business logic at the Oracle Service Bus layer that says when certain events happen, I want to trigger other things inside of my organization. When an order comes through that's greater than $500,000, let's say, I might want to trigger some different business activities. I want to maybe alert people or do additional security monitoring on those pieces that go along with that particular order. I can do that at the Oracle Service Bus layer without affecting my web services or my composite applications that are using those web services relatively easily. As of April 2014, I'm recording this video in October of 2014. As of 2014, there was a whole bunch of different versions available of JDeveloper to do SOA development. And it can be a real challenge because Oracle is trying to add all of this different functionality for different business users. So if you went to the OTN page to download Oracle JDeveloper, which is again what we're going to use for our examples, you would see that there's all of these different versions, and you say, I want to do SOA development. Which version do I download? As of October of 2014, it's a lot easier, but let me just go through this so you understand all the different details. The 12.1.2 version of JDeveloper was the latest and greatest, had a lot of really cool features in it, but no native SOA development capabilities built into it. The 11.1.2.4 version had a lot of really cool ADF mobile stuff, but no SOA. 11.1.1.7.1 had cool cloud stuff in it, but again, no local deployment, so it didn't have true SOA capabilities built into it. 11.1.1.6 had a lot of cool cloud stuff in it, but no SOA. 11.1.1.7 is the version that we wanted to do for SOA development. As of October 2014, and I didn't update this slide, but as of October 2014, there's a new version of JDeveloper that has SOA and all the SOA capabilities built right into the core product, and that is Oracle JDeveloper 12.1.3. It is a big download, but it has all of the SOA pieces built right into it natively, so you don't have to do any add-ons or anything like that. As soon as you download it, you'll have all of the SOA capabilities. That's the tool that I'm going to use for the demos that go through all of the videos that are part of this web series. So I'm going to be using 12.1.3. I'm going to be using Oracle WebLogic 11G, and I'm going to be using an Oracle 12c database as my backend. Why use Oracle JDeveloper? You don't have to use Oracle JDeveloper if you don't want to, but there's a lot of really nice benefits to using Oracle JDeveloper. There's a tremendous amount of tools that are built into JDeveloper, tools that are specifically designed to make your development environment a heck of a lot easier. There's editors, wizards, frameworks. We're going to look at some of those as part of our demos, but again, we're not going to get into a lot of tutorials on how to do these specific things inside of. The integration of the tools is spotless. So when it comes time for you to deploy your applications, it's an incredibly simple process for you to go from your development environment to your production environment to your test environment. If you want to integrate with tools like source version control managers. There are hooks built into JDeveloper that allow you to integrate with a whole bunch of different tools relatively easily. Even for simple projects, you probably want to start looking at those things because there's a tremendous amount of files that are generated as even part of the most simple JDeveloper application. You're going to have XML files and Java files and these crazy files all over the place. And if you don't have a real good source control system to manage all of those different pieces, you're going to be in trouble in a real short period of time. JDeveloper integrates with the database seamlessly. You can look at information inside your database. You can alter your database from right within JDeveloper if you want to do that. It integrates with WebLogic natively incredibly easily so that when it comes time for you to deploy your applications, it's real easy to do. I mentioned the development tools that are out there, Maven and source control systems. JDeveloper integrates with all of those different pieces relatively easily. It's updated on a regular basis. Oracle has positioned JDeveloper as its primary development tool for enterprise development moving forward. So there are a tremendous amount of updates that come along with JDeveloper on a regular basis, and the cost. It's free. JDeveloper doesn't cost you a dime. You can download it and use it for free. There are other Java IDEs out there that you can use. A lot of developers like Eclipse, IntelliJ, NetBeans, JCreator, they're all perfectly acceptable ways of creating an integrated, an application using an integrated development environment that's not JDeveloper. For the examples in these videos, I'm going to be using Oracle JDeveloper because I think that is the best tool out there for creating SOA-based applications, but you can certainly use any of those other pieces. Why do web services exist? Well, the technology that allowed the internet to happen is a technology called TCP/IP. TCP/IP allows computers with heterogeneous operating systems, networking systems to all communicate with each other, and that's what really made the World Wide Web explode, is the protocol that allows all of these different types of computers to communicate with each other. The technology that enables distributed computing is web services, and we've talked a little bit about what web services are at this point. They're little pieces of code that do a very specific piece of functionality, and then we can, like I said, start putting these different web services together into what are called composite application. So a web service uses XML to exchange information with other software using common protocols. There's a different type of web service that we're going to take a look at called REST, where we're not limited to just using XML messages. We can use other types of messages inside of our web services. But for the most part, XML is kind of the most common de facto way of exchanging information between web services and your applications. Web services encapsulate a very specific task, and this is where a lot of developers struggle. How specific should the task be for my web service? I used an example earlier of an onboarding process. Should the whole onboarding process be one big web service, or should it be a series of web services where I grant access to the network, I grant access to HR, I grant access to the building, and I go through and I create all of these different things? How granular do we make our web services? When it comes time for us to start actually building web services as part of the demos, we'll take a look at the granularity of web services and how to make decisions based on that. But a lot of it is more of an art than it is a science. There's no right answer for all organizations or all groups of developers. Everybody is going to have to make their own decisions when it comes to that. And it self-describes itself. We said that if a web service follows all of the standards that are out there, it should be relatively easy for us to discover the service and figure out what type of information it wants and what type of information it's going to return to us, and that it can be discovered somewhere on our network. There's a lot of different competing technologies. For those of you who are interested in distributed computing, some of these terms should be familiar to you. They were very common in years past, but they all had some serious limitations. CORBA stands for Common Object Request Broker Architecture. DCOM was created by Microsoft. That's Distributed Common Object Model, and RMI stands for Remote Method Invocation. The key differentiators between these technologies and web services is that web services work over HTTP, which eliminates almost all of the firewall issues that are out there. CORBA, DCOM, and RMI have some real serious security concerns, especially when it comes to firewalls inside of organizations. The main language that web services use is XML. Again, there's a different type of web service called REST, where you're not limited to just XML. You can return other different types of information in different formats, but for the most part, XML is the most common way of relaying information between web services. And composite apps can use web service developed on any platform in any language. Again, I have any with an asterisk there because that's the promise of web services. Is that true in 100% of the time? Obviously not. There are some weird circumstances where you may not be able to communicate with a web service because of different issues that are out there. But as long as your applications adhere to the SOA standards, they should be able to exchange information between different services relatively easily. So again, you can think of a web service as kind of a little piece of code that does something, and again, this can be in virtually any language, and a web service wrapper that goes around that little piece of code that describes it, that allows people to get access to that information inside that little piece of code. That's really what we're talking about when we're talking about web services. And most development tools, and we're going to see how JDeveloper does this also, can generate that XML web services wrapper for you automatically. So you can focus on creating your code, this inner box here, the code that actually does something that can be in any language. That's where you can focus your energies, and then use some of the wizards in a tool like JDeveloper to create the web services wrapper for you relatively easily. How do we create web services? Well, do we start in a basic philosophy of top-down or bottom-up? And again, there's no right answer. Every organization is going to have to struggle with this by themselves. A top-down philosophy starts with the business services, then identifying the information services, identifying the technical services, and creating web services that are based inside of your organization. This sounds like perfect sense. But the services may be too abstract depending on how your existing architecture is set up inside your organization. The opposite of this is to approach creating web services as a bottom-up approach. And that's where you look at your IT assets inside your organization, you derive services from those existing pieces. What the challenge with that is that there's going to be a lot of customization, a lot of getting your web services to the point where they're generic enough where they can be used across a lot of different disciplines. Remember, we talked about this earlier. It's going to take a lot of work if you do a bottom-up approach. So there's no one right answer. Again, every organization is a little different. They're going to have to work through these issues themselves. And again, as we go through our examples, we'll start seeing some of the challenges that go along with both of these approaches. Typically, the steps that you go through to build a web service is that you define the functionality. What is the web service supposed to do? What inputs is it taking? What output is it going to return back? Then you design the interface, and you can think of designing the interface. If you've been working with PL SQL for a while, you can think about how you structure a package and how you structure the package header. This is how you define how people are going to get access to the information inside of the package, the functions and procedures inside of the package. You define the interface that goes along with it. You design the contract, what type of information, when it's going to be available, all of those things. And then the actual implementation of the web service. You start writing the code that replicates the business logic that you want to have inside of your web service. Granularity is really a tough nut to crack because every organization is going to be a little different. How granular should your web services be? Should there be one onboarding service or service for each step? How granular should a release be for your web services? Well, it should be big enough to provide value on its own, but small enough so that if you change it, it doesn't change the entire IT landscape. So again, if you make your whole onboarding process one web service, making a change to it is probably going to affect just about everything about the onboarding process, and it's going to affect your entire IT landscape. So that's probably not granular enough to make a web service that encapsulate the entire onboarding process. You're probably going to have to go through, drill down a little bit more, and create lower layers of granularity as part of the onboarding process, and then use a tool like Beeple to create a composite application that brings all of them together. And it should be derived from the basic functionality of what you're trying to accomplish as part of your web service. Hand in hand with transaction boundaries, there is no one correct granularity. This makes sense, right? So in terms of transaction boundaries, again, if you made your onboarding service one big web service, there's probably a lot of transactions. There's probably some place where you store networking information, some places where you store HR information, where you store payroll information. One web service is going to cross multiple transaction boundaries. So it's probably a lot better to make more granular services for an onboarding process. Two basic types of web services. SOAP was popular for a long time. That was Simple Object Access Protocol. And SOAP web services were the de facto standard for a long time out there. There's a whole bunch of standards that start with WS, Web Service Standards, and the interface describes the available operations, the input-output, the technology binding. SOAP returns XML. Recently, a new type of web service has really gained in popularity, and that's called REST. REST stands for Representational State Transfer, and it's a formal model that's based on resources where you send a request and you return a resource that shows options for the next steps. REST relies on gets, puts, posts, and deletes, which are HTTP verbs that are used inside your browser to do different things. Now, I have this little parentheses here that says look familiar. What do gets, puts, posts, and deletes kind of look like in the Oracle world? Don't they kind of look like select, insert, update, and delete as part of our database transactions? Kind of look the same, don't they? So REST dovetails real nicely into the typical things that we do in a relational database. So there's a lot of really cool ways where we can hook those different types of HTTP verbs and the types of actions that we do in a traditional relational database together. REST also has a lot more flexibility in terms of what it can return. It's not limited to just returning XML. It can return HTML. It can return something called JSON, which we're going to look at as part of our examples. There's a parser for XML and JSON built right into the Oracle database. So we can get that information and then use tools inside the Oracle database to make sense of the information that we get back from our web services. So again, you can think of a web service as a black box of functionality, but only think of it at that very high level. As we start drilling down, we're going to see it's a lot more complex than that. We don't want to just limit our thinking into web services. What we're going to do in the next video is we're going to go through and look at a real simple way of creating a web service with JDeveloper. When we come back, we're going to start looking at some of the other technologies that are built into some of the tools inside of Oracle WebLogic and inside of Oracle JDeveloper that allow us to create these really complex SOA applications relatively easily.